Okay, so I'll be explaining the first ionization energy for period 3. Period 3. We're going to period 3. Okay, first of all, we have sodium. Okay, ionization energy, so it's just the elements first. Okay, first ionization energy, so we're starting from the atoms. Okay, magnesium, aluminium, then we have silicon, then we have phosphorus, sulfur, then we have chlorine, and then we have argon. Okay, I'm going to include argon this time. Okay, for sodium, generally it's going to be lower. Okay, magnesium is going to be higher. I'll draw it a little higher so it's easier. Then aluminium, I'll draw it like that. Sodium, okay, no, silicon, phosphorus. Okay, so this is one. After that, what do? You do a little drop. Then the rest will be just rising. Okay, so let me connect this together. Okay, something like that. Okay, so the reason why I dropped here, I'll explain why, is actually why there's a decrease. Okay, but just bear in mind, okay, this decrease cannot be like that, such that this part is lower than the previous one. Okay, it can only be lower by a little bit, so essentially it's in the middle. See, it's in the middle. See, it's in the middle. Between this and between this in the middle, it cannot drop too much. Same for this. Likewise, this part must be in the middle of this and this. Okay, it cannot drop too much, okay. So first of all, I want to explain the general trend. General trend is increasing, like we all can see. General trend is increasing. Okay, why is the general trend increasing? Again, this for first ionization energy. Okay, first of all, from sodium to argon, the proton number actually increase. Therefore, your nuclear charge actually increase. Okay, so then again, successive electrons added to same outermost electron shell. Okay, same thing. How does it work is that if you did not watch the previous video, I made it this like that, right? This is my sodium. Okay, sodium, I have 1 electron. Sodium. What happens if I'm going to make it into magnesium? What I do? I change this to magnesium, and I add another one. I want to make it into aluminium. What I do? I'll add another one. If I want to make it into what, silicon? What I do? Add another one. So essentially, I'm just adding to the same valence electron shell. Okay, that's what it means by adding successive electrons. It means adding 1 electron. Okay, same outermost electron shell. So therefore, no. It means relatively. Relatively the same. Between what? Between all these elements, shielding effects remains relatively the same. So what is different is the nuclear charge. So essentially, effective nuclear charge actually increases. Because how do you calculate effective nuclear charge again? Go back to our formula, good old formula. Okay. Effective nuclear charge is nuclear charge and shielding effect. If shielding effect remains the same, nuclear charge increases, the overall will be an increase. So this is the same thing for this. So you increase the effective nuclear charge. So the net attraction between the nucleus and the valence electron shell actually increase the net attraction. Net attraction. You're gonna write short form. You must tell me net attraction between what and what. It's between silicon and between the nucleus and the valence electron shell. So then therefore more energy needed to remove first electron from outermost electron shell. So now what? So now you've told me that therefore the first ionization energy increases. Okay, it's because the attraction from the nucleus to this actually increases. Okay, thus it actually holds on to all these electrons more firmly. When it grapples onto these electrons more firmly, it's difficult for you to rip it out, for you to take it off. It's very difficult for this to go away. Should I move like that? It's very difficult for this to move away. If it's difficult for it to move away, then what happens? more energy is needed to remove it, right? So therefore its first ionization energy generally increases. But there are some trends. I'm going to explain the presence of dippings now. Okay, magnesium. Let's explain aluminium and magnesium now. Generally for aluminum is it's how do I say, its electronic configuration is 1s2. You can practice with me now. Okay, 2s2, 2p6, 3s2, and 3p1. Magnesium is 1s2, 2s2, 2p6, 3s2, and 3p. There's no 3p. It's just like that. Okay, so the reason is because lesser energy. Where's the lesser energy? The lesser energy is here. Lesser energy for this is needed to remove a 3p electron from a higher energy level 3p orbital. 3p subshell. Okay, how do you know which one to use? Orbital and subshell. If it's just 3p alone, or p, it is actually subshell. What is a shell? Shell is 1, 2, 3 your shell. So it's in other words, if I say first electron shell, it means it's the most inner one. So first electron shell consists of 1s and 2s. Second electron shell consists of this. Okay, and then within this is actually your subshell. Okay, what is your orbital? Orbital is what? Orbital is actually a 3px, 3py, 3pz, or 3px squared minus y squared. That one is your 3p. Okay, so this is your orbital. Okay, so we will talk about orbital later. Okay, so now it's because lesser energy over here. Okay, aluminium has lesser energy, lesser ionization energy is required. Lesser energy is required to remove and a 3p electron from the higher energy 3p subshell. This is higher energy, so you must tell me this is low energy, this is higher energy. Okay, that's why. Okay, now we talk about between phosphorus and sulfur. Again, phosphorus is very easy. Just write 1s, 2s. Again, the reason I'm not writing the noble gas in the electronic configuration, okay, because I need to show. Okay, actually this part you can convert into noble gas in the electronic configuration, but over here you need to show. Okay, 3px, 3py, 3pz. Okay, so how do you show? P is actually like that. Okay, so S is actually same thing. Okay, 3p 1 x2 3p. You can put y actually if you want. 1pz1. So essentially it will be like that. So in other words, there is one more electron, a presence of an 3px. You must follow. If you write x here and you put a 2 here, so you write like, in other words, alternatively you can write 3py, then you put a 2 here. If you put a 2 for y, or you put a 2 for z, it's not put for everything. It's either you put for x, which is what I did here, put for y, or this is y, put for z. Okay, you only can choose one. If you put for y, just tell me that there's a electron pair. This is a paired 3x electron. So this is a paired 3y electron. Okay, when it's a paired, it means that it experiences inter-electron propulsion. What does it mean? Electrons, we know they are both negative, right? They repel, because they are in the same orbital. Okay, let me give you an example. Okay, 3p, I just draw 3p. Okay, this is not the best drawing. Pardon me, because I'm not taking A levels. Sorry. You are taking A levels, not me. Okay, so anyways, it's like that. So you always have to label 3px, 3py, 3pz. So this you don't have to draw this in exam. They won't ask you to they will ask you to draw this, but they probably won't ask you to explain. But if they do, then good for you. So how it works is that remember when you fill up the orbitals, you have to fill up first, right? I have 3, so I have to fill up like that. On the first side, then I have to fill the bottom one. Okay, what happens is that this X, for example, it has already 1 electron. Y has 1 electron. Sorry, this shall be Z. Z also has 1 electron. P, this and this. Okay, these two are orbitals. Orbitals basically is an area where there's a higher chance of you finding an electron moving around it. So 3px, okay, there's 2 electrons, so it's an electron pair. By the way, each of these only can contain one pair of electrons, basically 2 electrons. So 3px is already full, it's already filled. Okay, so in other words, there's this what inter-electron repulsion okay, while those that's orbiting 3pz only by itself there's no friend, you know, okay, it's just by itself only, 3py also. So in other words, this experiences inter-electron repulsion, so means what? Repel repel already, then repel, then it will be less energy to remove it, right? Because it's like I two thing, imagine my E minus my electrons they're repelling, means they're fighting so essentially if a teacher come and take this student away, isn't it easier to take them away? Because they don't like each other already what, so it's easier to take them away. Easier means what? Less energy required to take them away. Okay, so that's how it works. You can take a screenshot if you want, but yeah, that's how it works. Okay.